Good afternoon. How's everybody doing? Hopefully you are here for AZ-201, the Microsoft Azure Developer Advanced Solutions. Welcome to the Mark Rusinovich, pour over room, right? Just kidding, just kidding. I know Mark's talking right now. So there's a lot. I saw a lot of folks. I had to kind of fight the crowds just to get to the room. I am Brian Swiger. I'm a cloud solution architect at Microsoft. I'm actually out of Tampa, Florida, about an hour and a half from here. Been a developer architect for about 20 plus years now. I am a Microsoft Certified Trainer, Solutions Developer, and Azure Certified Developer and Architect. So I dog food these exams. I take them myself, several exams, and I encourage you to do so. I don't always pass every exam. I study the best I can, but I do go take exams and I use them to learn and develop, essentially grow myself. And I've also been active with Microsoft Learning and exam development for 10 plus years. So I try to help out, contribute where I can. You can find me on Twitter at CodeBeing, and that's my personal site and my blog as well. So what are we here for? Today's session, we're going to look at kind of a certification overview. We're going to look at the exam overview and the objective domain. So that's all of the topics that are going to be on AZ-201. What are those topics? What do they look like? What do I need to know when I study for this particular exam? We're going to look at how to prepare for the exam and some tips and tricks from an MCT. And then what I want you to do walking out of here to take action. So the key takeaways, again, we're going to look at some exam study material, links, and resources that you can use to study and prepare and hopefully pass the exam. And we're going to look at topics and the breakdown of questions and kind of the structure of questions, essentially. So starting out, a certification overview. What do we have from a certification perspective? As you noted in the keynote this week, we're announcing Microsoft Learn. We have 4 new Azure job role certifications and training associated with them. So we have the Azure Administrator, the Azure Developer, the Azure Solutions Architect, and coming soon is the Azure DevOps Engineer. So what we're here and focused on is the Azure Developer. This is the second in a 2-part exam for the Azure Developer job role. So starting out from a certification perspective, we're looking at the fundamentals. We have the Microsoft Certified Azure Fundamentals. This is an optional path here. And then we have the associate level. We have the Microsoft Certified Azure Administrator Associate and the Microsoft Certified Azure Developer Associate. And of course, we're going to have more roles coming out soon as well. So a lot more job roles and focuses for training and certification. And the next level would be the expert level with the Microsoft Certified Azure Solutions Architect Expert. And again, coming soon, the Microsoft Certified Azure DevOps Engineer Expert. So in that lower right-hand corner, we do have transition exams available if you've already taken any of the 70 exams. So the 532, the 533, and the 535. We do have associated transition exams for all of those. So for this particular exam, it would be AZ-202 would be your transition exam. So if you've already taken 532 and succeeded, I would like you to go and take AZ-202 as that transition exam. So the Azure Developer job role. What does an Azure developer look like? So essentially, you know a language that's supported by the cloud. So you're going to have a cloud-supported language. If you're a Java developer, if you're a Node and JavaScript developer, you're a C# developer, a VB.NET developer. So a developer that's going to coordinate with cloud solution architects, DBAs, some of these other roles to essentially implement the solution. You are a developer. You are implementing the solution. You're coding. You're implementing the solution, doing JSON files, et cetera. So as I talked about, this is the second part of a two-part exam to achieve the Microsoft Certified Azure Developer Associate certification. So we're here for AZ-201. I had a session prior in this week for AZ-200, which is the Core Solutions exam. So the Microsoft Azure Developer Core Solutions exam. And this exam is AZ-201, which is the Microsoft Azure Developer Advanced Solutions exam. And you'll see there the breakdown of all of the various topics that are on both of those exams. So once you have achieved both of those exams is when you would receive the certification. So we're going to focus in on AZ-201. So we're going to look at the exam overview and objective domain. What do we mean by an objective domain? Essentially the topics, the outline of what topics that we need to understand to accomplish this exam. So starting out, some exam basics. If you've not taken an exam before, they are typically 40 to 60 questions. Some questions are worth more than 1 point. And you want to make sure that you answer all questions. There is no penalty for leaving, for guessing. You want to make sure to answer every question. And note that some questions cannot be skipped. I always encourage you to take your time on an exam and read the text that you're presented. It'll tell you if it cannot be skipped. And always encourage you to mark items for review as well. So you can mark them for review. If you're not sure, go ahead and guess on that question, mark it for review. You'll see a checkbox on the screen to mark that item for review. You can come back and review that once you get to the end. You can also comment on items. So there are folks that read those comments and will update items accordingly if it does make sense. If there's something wrong or verbiage or phrasing or something wrong with that particular item, please do comment. Your comments do impact the exam development. People do read those comments. So plan for about 180 minutes, typically around 150 minutes to answer the questions, and then 30 minutes for reading the instructions, and then also to give time to comment. Like I said, comment on the items, and just read the score reporting at the end. Note that they are more than multiple choice questions. They're different types of questions. We might have to put stuff in order. We might have to drag and drop items, especially maybe a portion of code. We might have to drag from one side and place it into an existing set of code. So understand there are different item types. Again, if you've not taken a Microsoft exam, I highly encourage you to go take it, even if you feel like you're going to fail. I always joke that your mom's not going to get your grade report. Nobody sees that grade report. But what's nice at the end of an exam, you get the report that tells you which areas that you were weakest in. So it does show you, oh, I didn't understand security as much, so I need to go study that particular area. So, but it gives you a good feel for what the questions are like, the different question types that are in there. And note, it states performance-based testing is coming soon. So what does performance-based mean? Essentially given a tasks or a set of tasks that you have to accomplish in an amount of time. So as an example, if I were to ask you to write a time-based function, for say a serverless function, so you would actually go out to the portal and maybe write that function to do or accomplish a certain set of tasks. So that's an example that you would actually have to get hands-on and produce. And lastly, we have case studies. These are the business case studies. They have a set of requirements, and they also have a set of existing questions that tie back to those requirements. So it's more of a real-world type business problem that would have business requirements, some technical requirements, maybe some areas of code to kind of understand what's going on and then associate and answer questions in accordance to that business case. So each exam does have a cut score. The exams range from 0 to 1,000. And note that if you walk out with a 700, that means you passed, and then that is not a 70%, because each question is weighted differently based on that cut score. So even though you got a 700, you should congratulate yourself and not feel that you got a C or that you got a 70%. Just note that you did pass. And the cut score is determined during exam development. It's based on the skills of the target audience and that difficulty that I was talking about, the difficulty of the item itself. So again, just to reiterate, answer every question. There are no points deducted for the wrong answers. And note that some questions cannot be skipped. So make sure that you read all the text on the screen and answer every question before moving on to the next one. Even if you want to mark it for review, you have no clue, pick some things, mark it for review, and then come back to it later. So what does an exam question look like? As a developer, I'm going to be given a technical environment or a scenario. So I'm a developer that is doing something, right? I'm a developer, maybe working, building a serverless solution, what have you. So I'm going to give a problem statement and some requirements. The app must accomplish these things, okay? And I'm going to have to do something. You need to accomplish a task, or you need to implement this piece of code, or you need to do something. And what should you do? Effectively choose a piece of code, make the correct setting. What should you do as your action? So AZ-201, the advanced solutions as we talked about, 3 different areas. You'll note that almost over half the exam is in the first category, develop for an Azure cloud model. So what are those percentages on the right? That is the percentage of the questions that are going to come from that particular category. So we have this set of questions in this pool, this massive set of questions, and the test engine is going to run, and it's going to pull from these different categories. And it may generate different tests every time, so you never know. You could go take it today, go take it tomorrow. You're going to get a different whole set of questions. So we have develop for an Azure cloud model, implement cloud integration solutions, and then lastly is developing AI, machine learning, and IoT solutions. You'll see the percentages there. Again, the breakdown of the amount of questions in each of those categories. So a large question I get is, what if I already studied for 7532? If I'm in the process, I've already started to study, I haven't taken it, but I'm already down that road. You could continue and go ahead and take 7532, but note that 532 is only available through December of this year. So the end of the year will be 532's discontinued, essentially. But a lot of the knowledge that you've already studied for 532 translates into AZ-201. The first area, which is half of the exam, does not, but some of the other categories actually do translate over. So some of your learning is not to waste, but I would tell you to target AZ-201 because there are a lot of new topics on this particular exam, especially around developing for that Azure cloud model. So what if I've already passed 532? What do I do now? There actually is a transition exam. So AZ-202, if you've already passed 532, go take AZ-202. That will accomplish you to get the new certification. So the AZ-202 will be available until March of next year. So you do want to make sure that you transition and get that transition exam under your belt if you've already accomplished 7532. So let's look at AZ-201 and the various topics on AZ-201. So starting out, half of the exam, as I talked about, developing for an Azure cloud model. We start out with developing for asynchronous processing. So this is understanding asynchronous processing across a various amount of interfacing, whether it be data access, whether it be straight code, implementing parallelism, multi-threading, durable functions. There's a little bit on logic apps in here. So as I said, interfacing to data and storage. So understanding asynchronous. And then auto-scaling, understanding auto-scaling rules and patterns. How do we auto-scale various compute across Azure? And understanding code that addresses transient state. And developing long-running tasks. So we're looking at implementing large-scale parallel processing. So this is a lot with, say, Azure Batch. And resilient applications using queues. So we have to understand what a queue means, how do we implement a queue, and the various queue options with the Azure platform. And then understanding webhooks and continuous processing with web jobs as well. So you'll see various links at the bottom here in these red boxes. I have them throughout the presentation. And of course, you'll be able to download this deck. But these links link to more information on those particular areas. So I'm going to talk later about studying for the exam, but one area is to read, of course, documentation. That's one step, but those are links to those various topics. We also have on, again, half of the exam here with developing for an Azure cloud model, distributed transactions. So understanding transaction scope and implementing distributed transactions across multiple databases and servers. Enabling search of textual content. So we're looking at Azure Search, creating indices, and being able to interface with Azure Search and work with results. And instrumenting an application. How do we instrument an app? With App Insights, working with Azure Alerts, dashboards, Metrics Explorer, and various metrics that come out of the platform or our applications that we can accumulate and show or work with. So again, the three focus areas is cloud distributed transactions, Azure Search, and then application insights. So let's start out with developing for asynchronous processing. We have three different models that have been around for asynchronous processing. The key focus from a development perspective is a task-based asynchronous pattern, or TAP. I'm going to tell you about all three, but TAP is the one that you want to focus on, essentially working with async and await keywords. This is the recommended approach for asynchronous processing. We'll talk a little bit more about that. APM is not recommended, an older model. This is the iasync result pattern requiring begin and end methods. So if you're still doing this, please move away from that pattern and use the task-based asynchronous pattern. And finally, we have the event-based asynchronous pattern, or EAP, and it requires the async suffix, but it's one or more events with event handler delegates. And delegate types with the event arg derived type. So we don't want to use this either. So we want to focus on async and await from a task-based asynchronous pattern. So why async and await? Async will avoid additional thread creation. It's going to run in that current context. And essentially, the await operator, if the await operator isn't used, that method's going to synchronously process. The await method is designating those suspension points. So we're going to await the operation. Once it completes, it's going to come back. And it's going to tell the compiler that async cannot go past that particular point until that process is complete. So we're going to make sure that it comes back and we can respond to that particular function. And it doesn't constitute an exit. So in other words, it's not going to exit your actual method. So when you see an await, you're not exiting that method. It's going to continue on in process. So we do have various APIs from .NET and the Windows runtime that do support async programming and async interfaces. From an application area, we've got web access. We do have the HTTP client and the syndication client. So these are from .NET types with async methods over to the Windows runtime types with async methods as well. So it'd be good to be familiar with these interfaces and or have used these particular methods and interfaces. And again, these are for web access, working with images, files, and WCF programming as well. So some of the best practices in async programming: avoid async void. So we always want to actually have an async task method. The only exception would be an event handler. And we want to use async all the way. We don't want to mix synchronous and asynchronous code if possible. The only exception would be if you're writing a console application, you have your main method there. But try not to mix async and synchronous processing. And then make sure to configure context. Use configure wait false when you can. And your exceptions would be methods that require context. So an example here, we're taking a synchronous method, essentially putting in the async and await, and we're going to return that task of action result. So very simple implementing asynchronous. And asynchronous does work with the entity framework as well for supporting inserts, updates, and deletes. So working with relational data and working with entity framework. It even works with link queries as well. So you can use async and await across entity framework as well. So that's asynchronous processing. We'll go into auto-scaling. So we need to understand, again, auto-scaling and our auto-scaling options across various compute in our various services. So we have two different types of auto-scaling. We can either vertically scale or we can horizontally scale. And vertically scaling is essentially resizing your resources, like a VM. If you were to scale that VM up, we need to realize that scaling that VM up does take time. So your application could be unavailable when you scale up. And it's less common to automate vertical scaling. So typically that's a manual process, but it is able to be automated. But since the application would be down and we're vertically scaling during that time. Horizontal scaling, most common to actually automate. We're scaling out and in, essentially adding other instances, say of a web application or an Azure or an AKS, Azure Kubernetes service node. So we're scaling that out and in. And this would actually not impact, or hopefully not impact, application performance or uptime. Well, we're hoping it positively impacts application performance. So there are some built-in auto-scaling options on Azure. All of these do use Azure Monitor Autoscale. So just realize a lot of these are based on metrics that come from various sources. So essentially you can use metrics that come, say, from your applications, the platform itself. But we're looking at metrics, information to actually do those auto-scale operations. So virtual machines, we've got virtual machine scale sets. So you can manage those virtual machines in a group, and a virtual machine scale set essentially will expand out and in and creating more virtual machines as needed. Service fabric, each node type in a cluster is actually a VM scale set. So if you're using service fabric and you're working with the node type in the cluster, it actually underneath is a VM scale set. So that is how we're scaling our application on service fabric. Azure App Service, we have built-in auto-scaling. We can manually or automatically, again, based on those metrics, scale out and in additional app service instances. In Azure Cloud Services, we have auto-scaling at the role level, and we can also configure auto-scaling through the portal for Azure Cloud Services as well. So these are the compute options and auto-scaling across the Azure platform. So here's an example of a rule condition To enable auto scaling, here we have a virtual machine. We have 3 of them. We can actually set the VM scale set to say from a minimum of 2 virtual machines that need to be up and running, all the way to 5 if my application is seeing a high load. We're going to go ahead and have it scale up to 5 virtual machines. So it'll add virtual machines, and it'll also remove virtual machines as needed. And we can enable auto scaling based on those various metrics. Those various metrics could be coming from the application, which we're going to show with App Insights, or it could come from the Azure platform in terms of memory usage, CPU usage, or other telemetry that I can get from the VM, the virtual machine itself. So here this might be a little bit difficult to see. There's a lot going on here. But again, it's based on the resource, which is the metrics that we're going to derive that scaling from. We may have a rule or multiple rules that we want to scale various resources with. Based on those metrics, we could scale the resource. We could also scale the resource based on time. So say it is a holiday that we want to scale on. If your business is around a particular holiday, we may want to scale during that week of that holiday. So we could base it on time as well. So we can also kick off various actions. We could send an email. We could have it call another system. We could obviously increase or decrease our compute resources. We could also kick off automation. We could have it kick off an automation runbook, maybe a serverless logic app or a serverless function, or even call a third-party URL or third-party service. So just understand there are various options here, but scaling is based on either time or metrics. So developing long-running tasks, we want to look at our queuing options on the platform. There are essentially 2 different queuing options that we're going to look at is the Azure Service Bus queue and the Azure Storage queue. Understanding the differences between these is critical when implementing applications, especially if you want a first in, first out queue. We want a queue that supports first in, first out. We're only going to choose Azure Service Bus queues. If we want to support dead lettering, if an application goes to a message goes to a poison state, that message couldn't be processed, stay within a certain window, and goes to a separate queue, a service bus queue is only going to be the one that we want to implement. So temporal decoupling of the application components, essentially, again, we're taking and decoupling components away from the overall application processing. For an Azure Service Bus queue might be really good for if you're implementing an e-commerce shopping basket for a web application. We might want to use that. But again, depending on your scenarios and your usages, especially the payload sizes and the amount of time that you'd like that message to reside on the queue is very important as well. So not only the first in, first out, and those capabilities, the message size itself and the length of time that it's going to reside on that queue. So here we have just an example message. The sender will send the message, say a web application, as I stated, might send a message to the queue, might be a JSON payload with the various items that I've added to my cart. So I want to purchase some things. I'm a gadget guy. I want to buy some stuff, put those in my cart. And again, the message is actually the body. It may be a JSON payload, XML payload, the message body, and then you may have additional key value properties concerning that. And that's going to reside on the queue, which may get picked up by another process to actually be processed. So maybe a logic app or a function, something else is going to pick that up. So again, it's dependent upon the size of the message and the length of time that we're going to decide whether or not we want a service bus queue or an Azure storage queue. Distributed transactions. What's really nice about distributed transactions is if we're working in ADO.NET or .NET Framework 4.6.1 or later, distributed transactions are pretty straightforward to implement even across multiple databases in the cloud. So if we have Azure SQL, we've got multiple databases, we want to do a transaction that spans those multiple databases, we can actually do so with, if you've done transactions before, it's going to look really familiar to you using the .NET libraries. So some of the limitations, though, is you cannot span those transactions across the cloud and on-prem. So you cannot do a distributed transaction between those two, and it's only based on a client-initiated transaction. So the application itself is going to have to do that transaction, not at the database level. So it's managed by the application. And currently, transactions across WCF services are not supported as well. So understanding cloud distributed transactions. This is just a quick example of that cloud distributed transaction. As I stated, you might have the client app, the coordinator, that's going to maybe insert data across multiple databases that we have in Azure SQL. It could be even, as you note here in the upper right, across multiple regions. So we have different databases across different regions we want to do a distributed transaction against. So if we're using an application that's using .NET Framework 4.6.1 or higher, we can complete that distributed transaction. And that's exactly what it looks like. The focus is the scope. So we're setting up a scope, a transaction scope, and completing that scope. So we've got two different insert commands, essentially, that are happening, and then we're going to complete those two inserts across two different databases. Azure Search. So Azure Search, and this is creating an application that's enabling textual content or using Azure Search, essentially. So what do we do when we use Azure Search? We do three different things. We index, we add data, and we handle the results. Those are the three actions, essentially, we're doing with Azure Search. So we really want to understand how to create an index and what it is, which is a persistent store of those documents. What are we searching? So we want to understand how to create an index using custom analyzers to customize that text processing in the search engine itself, and understanding what a synonym is, which is associating the equivalent terms to expand the scope of the query itself. So those three concepts we have to understand when we're learning around indexing. Any of these services, and I'll repeat this later, but any of these services, I always say get hands-on. Go create a small application, maybe a console app or a small application of some sort of web app that actually uses the service. So implement Azure Search. As you walk through the implementation, and there are several labs that are out there, as you walk through the implementation, you'll find that you'll do these actions, and then you'll know them right on the exam. I know I need to index, then I need to add data, and then I need to handle the results and actually display them and page through those particular results. So as you implement all these features, you will see and know the various steps associated with them. So the second step is to add data. So we're going to push data in JSON format using .NET SDK or the REST APIs. Almost everything in Azure is supported with RESTful API calls. And then we're going to pull with the indexers supporting Azure Storage, the SDK, or REST APIs again. And finally, we're going to handle those results that we get back and customize the results page. There are various options to customize the results that return, and we can provide self-directed drill-down navigation. There's a link there that talks about faceted navigation, different concepts around Azure Search and search results. So application insights. How many folks here have actually worked with application insights and implemented it in their applications? So quite a few. So what is application insights? We're providing telemetry directly from our applications. We're going to send that telemetry back to the Azure portal to be able to read that telemetry, display it, do actions based on it. Like I had talked about, maybe scaling our application. We may just want to know how many items that somebody's buying per second. We want to know those kind of things directly from our application. What's interesting about Application Insights, this supports both on-prem and cloud-based applications. I always tell people this is one of my absolute favorite things as a developer. Implement Application Insights. You will get telemetry information that will save you one day, because all of that information is pumped back, and you may have a problem in the future, a performance problem, or an actual bug in your application. Application Insights gives you a lot of that telemetry that may save you. And it's super simple to plug in. Doesn't matter what language that you're using. We support all kinds of languages, .NET applications, Node applications, Java applications. And it's essentially a small instrumentation package that you plug into your application, a small snippet of code that you can send back the telemetry. It can be custom telemetry that you define. And again, it's all the way back to the Azure portal, supports on-prem and cloud-based applications. And the portal is just used to be that data collector so that we can visualize it and understand that information. That information can be pumped out to other applications. So say you use third-party applications to do data analysis or already have a telemetry application, you can pump that out of Application Insights as well. It's one of my favorite features. It actually has saved me several times. So here's an example. We have maybe some web pages or web apps and client applications. We've put Application Insights inside of those applications, so we've already instrumented them. So we went into the code, we added our little snippet, maybe a web service, an API of some sort. However, we have that hosted, maybe some background services. Those background services might be running on-prem. And it's going to send all of that telemetry to Application Insights. As I said, you can do a lot with that telemetry once you have it, but you have to have the telemetry and information. So you can output it essentially to Power BI dashboards if you want to do visualization and reporting. You can output it to Visual Studio, alert folks with that telemetry if something's you're seeing too much processing or slowdowns or performance, you can send out alerts as well. So the biggest question around App Insights is, what's the overhead on my application? Is it going to slow down all those apps if I go in and instrument all those applications? To be honest, there is minimal overhead. There is an overhead, very, very minimal. Always do performance testing and load testing of your applications, but very minimal load, especially since all of those calls sent back to the portal, all that telemetry information, they're non-blocking and they're batched up to be sent back. So it's very minimal impact, but it does have an impact. So implementing cloud integration solutions. Next section, we're looking at a quarter of the exam to maybe a little over a quarter of the exam. We're going to look at API management. So APIM, we're going to understand how to set up policies with APIM, how to host an API, of course, in APIM, and configuring authentication. Here we're going to go deeper into message-based structures. We talked a little bit about queues earlier, but this is more around an actual message-based structure with Event Grid and some notification hub, event hubs, more deeper into Service Bus, and configuring queries with across multiple products, and then Microsoft Graph as well. So here we may have to do some, or look at Microsoft Graph calls, and understand what Microsoft Graph impact to our application is. And developing an application message model. So creating a message schema, we want to understand how to create a common schema and message exchange amongst our application, an event model, and understanding topics and subscriptions. So these are the 5 areas of focus for this particular section. So APIM, API management, creating an API gateway. What is an API gateway? It's essentially a reverse proxy. We're looking at a reverse proxy to route requests from clients to services or hosted services. And it may do multitude of tasks. It may do SSL termination, may actually handle authentication. A lot of times APIM will do rate limiting. If you want to create an API that you want to monetize, that you want to say, you can only do 200 transactions in a day on this particular API, API management can do that with rate limiting. We do that through policies, which we'll show here in a little bit. So how do we actually implement an API gateway? This is API gateways in general. So APIM is actually an API gateway. And you can actually implement API gateways with a reverse proxy server, such as HA proxy, service mesh ingress controllers with Istio or Linkerd, and Azure Application Gateway. And I got a couple links there to show them. But the focus here is just understanding API gateways, their usage, and then, of course, we're going to focus in on Azure API Management, or APIM. So integrating Azure Cognitive Services in an application. Again, this is about 20 to 25% of the exam, so maybe a quarter of the exam. So we're going to look at cognitive services, speech, natural language processing, integrating Bing search into our applications, and creating and integrating bots. I love building bots, a lot of fun. Different bot types and how to build them with the bot framework, as well as integrating natural language processing with our bots. And creating and implementing IoT solutions. So if you don't do this on a day-to-day basis, maybe in your job, I personally do not, so I have to go study this area. IoT solutions with IoT Hub, understanding how to register devices and device provisioning. And Azure Time Series Insights, so understanding slices of time to analyze incoming messages from our devices. So those are 5 key areas here, or 5 links to help you study in this particular area. So the Microsoft Azure AI platform, what do we need to know here from an AI services perspective? For this particular exam, we're looking at the cognitive services that I talked about and the bot service. We're not particularly interested in Azure machine learning for the AZ-201. But the Azure AI services do include machine learning. We need to understand how to integrate our cognitive services and the bot service and building bots. So we just want to understand that Azure infrastructure supporting Azure AI services. So we may actually build a bot that may call into Cosmos DB or use some of these compute models as well. And finally, the tools, the different tools that you can use to integrate AI. So Visual Studio, of course, or Azure ML Studio, Azure ML Workbench. No, this exam is not getting into Azure ML Studio or Azure ML Workbench. Again, we're staying away from the machine learning. We're focused in on the bot service and cognitive services. So our different options across the cognitive services, we do have vision, speech, language, knowledge, search, and labs. The key to the exam is understanding all of these different options and how to integrate them into an application. Okay? So with vision, we're looking at faces to feelings. We actually can analyze someone's feelings based on the Vision API. With speech, we want to identify speakers by their voice, hear and speak to the users by filtering out noises. So again, we're integrating these into our application. So it's understanding the different options that we have with the cognitive services and then integrating them into our particular applications. So here we have language understanding, or LUIS. The key here is looking at intense as well as entities, so having an entity and an intent. And again, this is JSON structure. So it's, again, a lot of the links will have you go out there and look at how to build these the language understanding model integrations. And they're very straightforward from a developer perspective because they're JSON structured and structures that you're familiar with. It's same with API calls that you may or may not be familiar with, but you know how to call an API in a RESTful manner. So I'm going to give you one example. This applies to several of these APIs or integrating these cognitive services. So this is an example of how to call the computer vision API. So we want to analyze someone's a face with the computer vision API. What do? Step one, we're actually going to authorize the API call. We need a subscription key. Where do we get that subscription key, or what do we, where do we pass that subscription key? Maybe in a query string, an HTTP request header, or the constructor of a client library. So I'm hoping everybody, if you're a developer, you know how to work with the query string, HTTP request headers, or the constructor of the actual client library, so putting something into a constructor. Step two is actually transferring the image, uploading the image to the service so they can do the analysis. So that is an HTTP post call to the API. So we're doing HTTP posts. So again, straightforward. Hope everybody can do an HTTP post. And then parsing JSON. So it's going to return the results which may have the analysis, of the image. And in this particular case, we're looking at the description and some attributes of that particular image. So we're just going to parse JSON when it comes back. A lot of the APIs, very straightforward in their usage. A lot of the work, obviously, is on the back end with the machine learning models that are running, but we're sending in information, letting the machine learning model run, and then receiving results and then parsing those results. It's a very straightforward implementation of the cognitive services. That's why I love all of the cognitive services. They're essentially there for your usage, and the integration from a development perspective is pretty straightforward. So it's understanding that integration. So how do we prepare for the exam? How do I suggest you prepare? Definitely get hands-on. Definitely read, obviously, and watch videos, things like that. But we also have some training aligned with this. So we have micro-learning, a step-by-step bite-sized tutorials. So it's hands-on learning with browser-based scripting environments. So we have a lot out at Microsoft Learn. If you've not seen the new Microsoft Learn site, I suggest that you go out and visit. A lot of great information there and a lot of good information, especially on these new exams. So online courses that are offered through Microsoft Learning Partners, LinkedIn Learning, Pluralsight. So use online courses and hands-on labs to learn. I always suggest the hands-on labs. Hands-on labs are a great way to get interaction with the various services and are bite-sized. So the hands-on labs are going to take a little bit longer, but it's always good to get, again, use the actual services and see what it feels like. You can read a slide, you can read an article, go to docs, and read the documentation, but it's always good to actually do the deployments, get hands-on with the code. And of course, we have instructor-led training. So we have blended learning, maybe in person and online, depending on that particular class and those needs. And we have various Microsoft Learning partners to help with that. And the certification, as I stated, oh, there goes my mic. I got it. My mic decided to fall. Sorry about that. The certification is out there at aka.ms/mscert. And we do have these role-based certifications that we're talking about today. And you can find out more information out there. And I've already linked to the existing exam details page out on the learning area. And if you scroll all the way down to the bottom of that page, you'll see there's various study groups as well. And we do have practice tests that are coming soon from our partners. I know folks, a lot of folks ask me, folks have used MeasureUp practice tests and various other practice tests. We do have those coming soon. And I do suggest usage of the docs, the Microsoft Docs site. The documentation is always going to be, is typically up to date with the changes. Azure is always changing. So the documentation is actually very good to read. If you don't know, you can actually scroll on the lower left, the very lower left corner of the documentation, and download that particular area as a PDF. So say you're on a long flight, you want to have some good reading, you can actually download the PDF using that link on the lower left of any area. Very, very good to do. So tips and tricks from an MCT. So what do I suggest? In the first 30 days, essentially what you're going to do is absorb as much information as you can. So we're going to go out to the doc site. We're going to read all of the documentation, as much information that we can. We're going to watch videos. We're going to watch an Ignite session maybe. We're going to absorb as much information as we can. So in the next 60 days, we're going to focus on what we didn't understand as much, or an area that we're not as familiar with. So say I'm not as good at data. We're going to focus on data, maybe do a hands-on lab in that time as well. So maybe gauge how you're learning based on those hands-on labs and get hands-on more. So in the next 90 days, you're getting ready to take the exam. So at the 90-day mark, we may want to do practice tests, see how we're doing on those practice tests, and gauge how we're going to feel and make sure we've already signed up to take the exam. So I always tell folks, 1 hour a day, whether it's during lunch, after work, what have you, take an hour a day to do that studying. So read an article, read a blog, watch a video. Try to take at least an hour a day. And always, two would be make sure don't be afraid to fail. I always encourage folks to go take the exam. There's a lot of times that Microsoft will have second shot offers around the exams. So I always tell folks, don't feel afraid to fail. Just don't let folks know that you're actually going to take that particular exam. And go take it, get that results, get your output of your results, figure out where you're at across the spectrum, and go back to the documentation. Read more documentation. Get hands-on. Do another lab in that particular area. So if I was low on security, let's do a lab that's around security. Use some of these new training options, these bite-sized training options to look at around security or, say, data, some of those areas that I'm a little bit weaker at. So know that, and taking actions. What do I want you to do? I'd love you to take the exams. They are available here at Ignite for half off. They are 50% off. There is a testing area. It's around room 223, I believe, that you can sign up and actually take the exams here at Ignite. Again, they're half off. And learn more. There is a hands-on lab area if you're in the expo. Microsoft Learn has a booth, and there's a hands-on lab area kind of behind it that you can actually do hands-on labs associated with all of these different topics. And then visit us at the certification and training booth in the immersion zone, again in the expo. And again, visit the new Microsoft Learn site and look at the new certification tracks and certification information. We have a lot more sessions. Like I said, I recorded a session or presented a session on Tuesday around the AZ-200 exam. And today's, of course, is the AZ-201 exam. But we have more sessions across not only the architect, the developer, and the cloud administrator role. So there are various other sessions, and look for those if you want to access the decks or watch the recordings in the future. And that is all I have for today. Any questions, comments, or concerns? The mics are open if you want to ask about exams, transition, or where you're at on your cert path journey. So any questions, comments, or concerns, and I can go back as well. All right. Well, with that, I'll still be here. If you have any questions, just come up and ask. But with that, have a great day. Appreciate everybody's time.